Guys, so I actually did a small mistake in question 7, and I think it is only fair if at least this one I solve it for you, because this is not easy at all. So the problem is that in the solution the direction of the rotation is wrong. That's the problem in question 7. So let's do it. So first of all, I already converted all the data into SI units, metric units. Okay, as you can see here, I determined omega E, omega A in radians per second, and the corresponding tangential velocities at gears E and A. So I'm going to start by doing a schematic to explain how all of this is working out. So first of all, I will sketch the outer ring, which is said to be rotating in the anti-clockwise direction. Okay, anti-clockwise is like this. So it means that, for example, at this point, which I will call point E, the velocity is VE, and it is to the left. Now, in the center, I have gear A, which I am told is rotating in the clockwise direction. So it means that at, for example, this point, I'll have a velocity A, and it is larger than E because I determined it before, and it's going to be this VA. And these are the two vectors that I have. In between points E and A, I have my gear B. Okay? And this is gear B, the one that I will use to do my kinematics analysis, because I know one velocity at E, I know one velocity at A, but I know two velocities at B. So, at gear B, that's what I will do, gear B. What I will do is the diagram, and what do I know? I know that the velocity at this point, which I called point E, is to the left and is VE. And I know that the velocity at this point here at the bottom, which I will call it point A, is to the right and is this VA. This is something that I know, because the gears do not slip. That's a feature of the gears. They are meshed together through their teeth. So now what I do is decompose this into a pure translation and a pure rotation as always. And this is a translation. I have to choose a reference point, I'll say with A, and this is rotation, and I will say about the pivot point, which I will say it's A. I selected A, I could have selected any other point. So this is my point A, so this is A, this is E, this is E, this is A, this is E, this is A. Okay, and now I'll sketch the vector. So pure translation with A means all the points move at the speed of A, so this is VA and this is VA. And rotation about A means that all the points rotate about A, or point E rotates about A in a pure rotation. Now, A is larger than E, so this suggests already that this wheel is spinning in the anti-clockwise direction, which is exactly the answer that we should be getting, and this is where I've written the wrong answer. This was a typo more than anything else, but okay, I assume the responsibility anyway. So here we have the diagram, and the equation I will write is going to be the one using the vectors on top, and I only have vectors in the x direction, so I don't need to decompose. What I have is minus VE is equal to VA minus VE with respect to A. So this yields to VE with respect to A is equal to, so it goes to VA plus VE. And at the same point, I have that VE with respect to A is equal to omega B, the rotation of these times 2 times the radius, so this distance over here, so 2 times R. Okay, so what I have is omega B to R equals VA plus VE, which yields to omega B equals to VA plus VE over 2R, or omega B equals, and now I just replace the quantities, at 1.0053 plus V, which is 0.6283 divided by 2 times 0.04, which yields to omega b equals 2. And now I'm going to use my calculator. 1.0053 plus 0.6283. And this divides by 0.08, gives 20.42 radians per second. And the rotation is going to be, as I can see here, anti-clockwise. So it's going to be anti-clockwise. And this in RPM, I just do 20.42. I divide by 2 pi and I multiply by 60. So I obtain 195 RPM.